Odd. All single row engines must have an odd number. No way to build them with an even number. They won't work. How many master rods does a 9-cylinder radial engine have? 1. How many would an 18 have? 2. How many articulating would a 9 have? 8. And 16 for the next one. What does a radial engine use instead of a camshaft? Cam ring, right. They can't put anything right in the center because you got a prop shaft there. So they use that big cam ring. All right, no specific questions. What a cool video, though. I would love it if we could get that guy to come teach at our school. I'm pretty much in awe of him. He's an amazing guy. All right. What type of valves are used on aircraft engines? Conventional poppet type. Conventional poppet type. And what shape can the valve heads be? Well, we had tulip, flat, concave, mushroom, yeah. Okay, how are the valves held in the cylinder heads? You should know this now because you removed them, right? With those little, remember those little keys and the special washer? Yeah. Okay, why do we have more than one spring on each valve? Valve float, harmonic resonance. Every spring has got a certain resonant frequency. And when the engine goes through that resonant frequency, the spring will not do an effective, I think of bouncing a basketball. Like if you move your hand at just the right frequency, you're barely touching that basketball, which is fine if you're trying to efficiently bounce a basketball, not fine if you're trying to use the spring action to close a valve. Okay, what's another name for a lifter? Tap, tap, tap it. Yes, they tap, tap, tap. And what does valve float mean? It means the valve is not closing completely. Well, if the valve doesn't close completely, how much compression will we make? None. And how much power will the engine make? None. Right. Okay. So we talked about sodium and the fact that it sloshes around inside the valve. Gets hot at one end of the valve and then goes up to the top of the stem, away from the cylinder head, or from the combustion chamber, and dumps its heat into the cylinder head to go off into those cooling fins. And what is the melting point of metallic sodium? We agreed it is 98 degrees. What happens if we expose it to air? Well, it's going to start to corrode pretty quickly, and it's dangerously close to catching fire. If you put it in the water, it will catch fire, which is weird. Did Mr. Cliff talk about the different types of fire extinguishers? A, B, C, and D? I think he did. What's an A? Paper, solids. Looks like a tent, campfire. B, black oil, liquids. What happens if you pour water on a burning liquid? Yeah. If you pour water on a boiling liquid, I mean, if you drown it, fine. But if you put the wrong amount of water on a boiling liquid, the water will instantly boil, turn to steam, and splash burning liquid all over the place, including you. And that's not good. What is C? An electrical fire. What happens if you pour water on electricity? Especially if you're standing at the other end of the water? Right. You'll give yourself a shock. Don't do it. Go turn off the circuit breaker. And then D is a burning metal. What do you do with a burning metal fire? Run away. Run away. That type of fire, there's really nothing you can do. There are special, no, halogen won't put it out, I don't believe. It's just too hot. I think with a metal fire, they use a special sand, and the sand melts and turns to glass, and it absorbs a ton of heat when it does that, and it encapsulates it, and that's about the only effective way. If you've ever, I've played with burning magnesium. I've got an old wheel from an old dead conveyor, and I cut up chunks of it and I take it up to my friend's cabin, and we will toss it in the campfire. And it's pretty intense stuff when that gets going. You're not putting it out. You pour water on it, it gets worse. You pour sand on it, it doesn't care. Yeah. Okay. What loads and parts must the crankcase support? Yeah, it's hard to get going, but once you get it going, holy smokes, stay away. What loads must the crankcase support? The cylinders, crankshaft itself is worth noting. There's a note in the FAA, and so that seems like something that would be nice to put on a test tomorrow. It must support itself. A little counterintuitive. Accessories, okay. Why must it be sealed? Well, what's inside of it? Oil. Do we want the oil to leak out? No. So we seal it. And then we vent it so that the blow-by gases can get out. What do we make our aircraft crankcases out of? Aluminum. Same reason we made the cylinder heads out of aluminum. It's lightweight. Cast or forged aluminum. Okay. These next two actually aren't on the test. Good to know. I think make a point of it in the shop. It's more for a note for the shop. What material is a crankshaft made out of? Steel, forged and then machined steel. It is the single most expensive part of the airplane engine, in excess of $15,000 for one. Harmonic dampers, crankshafts, most of them do, especially longer engines use these harmonic dampers. Okay, how is oil delivered to the crankshaft bearings? Metal cast iron, not cast iron, hardened steel, forged steel. Cast iron isn't strong enough. We want steel for our crankshaft. What's the difference between iron and steel, Merken? Ooh. What is the difference between iron and steel? Steel has carbon in it. Steel is stronger. They are both ferrous. They are both ferrous. Iron and steel are both ferrous. You can pick them both up with a magnet. They're both really heavy. Steel is an advanced form of iron. We got to the Iron Age, and then we figured out how to make steel in a blast furnace. And it's just significantly stronger the way the carbon gets in there. Okay. How is oil delivered to the crankshaft bearings? Well, it comes up through passages drilled into the crankcase. All right, spun bearings are so dangerous because those holes need to line up, and you will not get oil to your bearings. How does oil get to the crank pins? Well, there's some little tubes. I don't know if I showed them to you. Inside the crankshaft are tubes that transfer oil from the main journals out to the crank pins. And if you haven't seen it, go to the back of the shop. There is a crankshaft out of an engine, and you can clearly see the little oil transfer tubes. They're really cool. Okay, this question here, I answered this yesterday. What is the clearance in the valve train of an operating hydraulic lifter? 0. 0, 0, 0, 0, 0. Why are they called zero lash lifters? Because the operating clearance is 0. Why is spun so dangerous again? Okay. Let's see. Bearings and bushings. Let's do slideshow. pin that. Oh, stupid thing. And this is one of the bearing halves, right? The bearing shells. See this little hole? That hole lines up with a hole in the crankcase, and oil, which I'm going to make blue for this demonstration, oil comes through this hole and coats the inside. So if this spun bearing moves 20 degrees, the hole won't line up. You see that? This little hole has got to line up with an oil passage. Does that work for you, Interviewer? It won't get lubrication. Yeah, exactly. The lubrication won't get through that hole. We'll have a dry bearing, and it'll last all of 2 minutes, and it'll tear itself to pieces. Yeah, the only oil would be just kind of whatever oil was splashed around there, and that they are designed depending on that pressurized oil. Good question. Okay, back to the engine parts. Okay. So why are they called zero lash lifters? Because there's no lash, there's no clearance. Why do solid lifters need to have clearance? To allow for expansion, hydraulic lifters. So what causes a hydraulic lifter to expand during operation? Heat? No. No, no, no. Oil pressure. Thank you. It is a hydraulic lifter. It uses a hydraulic fluid. We have engine oil in abundance inside of our engine, right around where that hydraulic lifter is. So we use oil pressure to fill a cavity inside the hydraulic lifter, and it hydraulically locks it to the full length. Well, if the engine heats up and we need to compress this lifter, how does the hydraulic lifter compress? I just said it's full of oil. Oh yeah, oil pressure is absolutely crucial. Oil leaks between the piston and the cylinder. There's a little, like the hydraulic lifter is basically a little piston inside of a cylinder, and oil is allowed to leak past. Okay, yes, oil pressure is a big problem if you don't have it. In fact, I did an engine run last Wednesday, I think, when I worked, and my job sitting in the right seat was to do nothing but watch for oil pressure when we did engine light off, make sure that we had proper oil pressure. And if I didn't see oil pressure, I was going to call it, and the mechanic, my crew lead in the left seat, was going to pull the emergency stop lever and shut it down before we wrecked anything. Okay. Where are the bearings for the crankshaft mounted in the crankcase? Anybody get that one? Transverse webs. Transverse webs, thank you. That's exactly it. And those webs are like an I-beam. How often is the valve clearance checked? Anybody? I talked about this yesterday, the day before. How often do we check the valve clearance if it's got hydraulic lifters? Good question. Looks like I skimmed past that. At overhaul or replacing a cylinder. Thank you, Josh. Perfect. So technically, anytime you overhaul an engine, you replace all the cylinders. So replacing all the cylinders and then also overhaul, because when you overhaul, you replace the cylinders. Okay. You can't check them daily because, or at any other time, because when they're full of oil, then the answer is meaningless. You need to disassemble it, take it out, clean it, dry it. It's just so hard to do that, and cumbersome. We don't do it. Okay, crankshafts are made out of forged steel. We did that already. What are the three main parts that all crankshafts must have? This is important to know tomorrow. Journal, crank pin, and crank cheek. And you should be able to identify them. What determines the number of throws? Well, the number of cylinders, right? What determines the number of throws needed for a radial engine crankshaft? The number of rows, right? Each row needs a throw. All right. And does everybody understand why V-types don't need as many throws? What do V-type engines use that allows a fork and blade connecting rod? Thank you. The fork goes one way, the blade goes the other, and two cylinders share a crankshaft throw. What's the advantage of doing that? Like, why not give everybody their own throw? Like we do on our opposed engines. Power to weight makes it shorter. Makes it shorter and more compact and lighter. Less weight and a shorter engine. Okay. So make sure you can identify those parts, those crank pins, crank cheeks, and journals. Where do you find dynamic dampers? Loosely but securely fastened to the crankshaft. Look at this, almost done. I'm going to take a break here soon, folks, I think. What does a connecting rod connect? What goes on one end? What goes on the other? Piston and crankshaft, yes. Which way do they go? Which one way goes to the piston? The small end goes to the piston. Thank you. 4 different kinds of connecting rods. What are they? Plain. I'll start you off. Plain is one. Fork and blade, and then there's the master and the split master, which is kind of a variation. Difference between a master and a split master is about the crankshaft. You just need a way to get them on. Okay. Why are there 4 different kinds? Well, they're used in different engines. And you need to be able to identify what kind of engine takes what kind of connecting rod. You're going to want to know how to do that tomorrow. Noted. Noted, right. Okay. Where is a knuckle pin found? Yeah. Located. It's what connects the master to the articulating rods. The wrist pin goes between the piston and the connecting rod, and then I think they were just out of joint names to use, so they called it a knuckle pin. It's a bit confusing. Now, why are the knuckle pins not equidistant from the center of a master rod? You're going to want to know this tomorrow. These are all things you're going to want to know tomorrow, but now and then I'm hitting one where you really got to know it tomorrow. Not in a circle, because they move in that oval to compensate for the oval path. Yes, that's it. Okay, what are pistons usually made out of? Aluminium. Yes, aluminum. And we talked already about the campground pistons, right? When we make them oval. Why do we make them oval? Because we want them to be round after thermal expansion has happened. Thank you, Nathan. What's the difference between a slipper type and a trunk type piston? The bottom end. Yeah, it's the piston skirt part. All right, typical shapes for the piston head. Domed, flat, concave. Where are the ring lands? Well, they're between the ring grooves, right? Ring land, ring groove. Yes, it's the space between the grooves. What's another name for the piston pin? The wrist pin. Thank you, Vincent. And where does it go? It connects the small end of the connecting rod to the piston. Why do we call them full floating in your Continental engine? Well, what secured that piston pin? Was there anything that held it in place? They were free to float around. Why didn't they fall out? Because they're kind of trapped in the cylinder. But as soon as you pulled the cylinder away, you were able to push them out, right? Nothing holds them at all. Why don't they score the cylinder walls? If they're running up and down against the walls, what keeps them from scoring? They've got aluminum caps on the end. Yes. All right, what are our two materials? We're near the end of this, and we're going to take a break at the end of this, folks. Probably take 10 minutes. What two materials? Cast iron, yes, and chrome-plated steel. All right. They go into the ring grooves. If you're using chrome-plated rings, what do you need to be aware of? Don't use them in a chrome cylinder. Correct. Don't use chrome-plated rings in a chrome-plated cylinder. Chrome on chrome doesn't work. That's all you got to remember. Don't use chrome on chrome. What are some cross shapes of the rings? Rectangular, wedge shape, tapered. Do you know what a dovetail is? It's like a blatant hint, but do you know what a dovetail is? A dovetail is a shape that looks like that, roughly. I can draw that better. Could you make a dovetailed piston ring? No. No, you couldn't. Good to know. Good to know. A dovetailed piston ring wouldn't work very good. That's in those nice to know things. Just might want to know that. All right. What is the purpose of the oil control rings? Well, we've covered that already. Why are cylinder heads usually built out of a different material than the barrels? Because we want to build them out of a lighter material. The cylinder barrels must be built out of steel to withstand the piston moving up and down, and the cylinder heads, we can save some weight by making them out of aluminum. What do we usually put in the spark plug bushings? Yeah, aluminum's got lots of advantages. It's just not that hard. What do we usually put in the spark plug bushings? Helicoil. Bronze or steel with a helicoil. Travis nailed it. Thank you, Travis. Why are there more cooling fins near the exhaust port? Well, it's the hottest part of the engine, or the hottest part of the cylinder, right? Okay. What are our two common processes that are done to harden? Chrome plating and nitriding. Okay, so how do we do nitriding? Our most common one. How do we do nitriding? Put it in the oven with hot ammonia or cyanide gas. Yeah, sounds deadly, and it is. Don't go in the oven. Well, it's 400 degrees or more. It is hot ammonia or hot cyanide gas. It would be deadly. Chrome plating, they use an electrochemical plating. They put it in a bath, they chrome plate it, and then at the last minute they reverse it to break the chrome plating and put a crack in it. All right, so what benefits do we get from doing this? Harder interior. So we get that tough base metal with a hard surface for the wear. All right, and again, I'm asking, if you've got a chrome-plated cylinder, what type of piston ring must you use? Cast iron. It's been asked a couple of times. Might be good to know. Cylinder choke, we already talked about that. We put it in so that when the engine is hot, it will be straight. So if it has no choke when it's cold, what shape would it be when it's hot? It'll be big at the top, right? Okay. Ooh, engine identification. Last thing here, and then we're done. How do you know if an engine is fuel injected? I. What is the opposite, if you will, of fuel injected? What is the alternate for fuel injection? Carbureted. So how do we know if it's carbureted? See, there's a lack of an I. Just not putting an I tells us that it is carbureted. How do we know which way the engine rotates? Which way do most engines rotate, right or left? Right. So do we ever put an R in the engine? No. Actually, we do. What does an R stand for? Radial. Okay, so if it's not a right-hand rotation engine, it must be a left-hand rotation, and we'll put an L. If it is not a fuel-injected engine, it must be carbureted, so we don't put anything. There's kind of assumed to be carbureted unless you get that magic I, right? The BMW 320i with a fuel-injected engine, right? Put an I in there. Now, naturally aspirated is the same kind of idea. It means it's not turbo or supercharged. It's breathing naturally. We're not forcing air into it. So how do we know exactly? No S or T. Okay, so what do we get to know? We get to know the number of, do we get to know the number of cylinders? No, that's a good question, Braden. The answer is there are no engines like that. Fuel injection is a modern, relatively, invention, and inline engines are really, really old. So that could be a problem. You might need to do an II, but they just didn't make any, so it never became an issue, right? So, like, what do you call a horse and buggy with disc brakes? Well, they didn't make them that way. So, by the time we got to disc brakes, the horse and buggy was dead. Okay, so what do we get to know? Do we get to know the number of cylinders? No. Do we get to know the horsepower? No. Do we get to know the displacement? Yes. And then we get to know, is it fuel injected or carbureted? We get to know if it's right or left hand. We get to know if it's turbocharged or not. We get to know vertical or helicopter installations can be indicated in there. What do the end numbers tell you? If you've got an IO 520-F, yeah, how can you know what the F or the D or the C means? You need to go to the overhaul manual or the maintenance manual. All right. That's it. You got to look it up. So just be careful. The letters at the end in the test center mean nothing. There's one other review, and I'd like to do that, but I think we're ready for a break, right? You guys want to do a break? You want to power through? I'm happy to power through. I'm doing fine, but there's only one more.